Um, okay, I'll hold it. I wanted to show you our perspective on IoT and IoT security, but looking from a little bit different angle. I totally agree with what Sandra said, that it's all about the privacy that needs to be taken into concern when you're talking about IoT security. And it's also true that most IoT vendors, they don't really care about security. I mean, it's unfair to say that they don't care. That's not their primary focus. So when you think about a vendor of IoT device, that's also true what Sandra said and what Tomasz said as well, that that device needs to be exposed to the internet as fast as possible. By all means, that's all about accessibility. And the security of it is the last piece of the puzzle that is most often missing or lacking. So they focus on embedding the security into their platforms, but the access to those platforms and to those devices is a little bit different story. So again, I would like to use one of the examples. So when you have a smart device like a wearable or a watch, although my watch looks like a smart, it's not smart. I try to keep myself sane, so I'm not using any smartwatches or anything like that. So if you think about the smartwatch, when is it useful? It's only useful when it connects to the outside world. What is the outside world? The outside world might mean a computer, but mostly that outside world will mean some other services. So if I have my wearable, my running device on me, it's only useful when I expose this data that this device produces to the external service that consumes that data and makes use of it. Without it, that's just a piece of junk on my hand, basically. So how do I make sure? There are some questions that I would like to ask myself before connecting any device to the network. How do I make sure that this device connects to the service that I would like it to connect? Also, when it connects, how do I make sure that the data that is being shared with that service that I just connected with is the data that I want to share? And how do I make sure that this data, once shared with the service, is not shared to any other third party? Currently, it is very difficult to achieve those goals. So that's why I deeply believe that achieving this goal of privacy, as Sandra said, and the goal of connecting the device to the right service requires establishing a trust. That's the only way that we can achieve that, or not achieve, but be closer to the holy grail of security. And to do it, we need to introduce something that is called identity. Without it, like I said, this wearable is just junk. Myself, I have a passport, so I have an identity. The service that I'm connecting to also needs to be identified specifically. So I want to link all of those entities into a single architecture that I would have insight in terms of sending the data, authorizing what can be done, what cannot be done. And there was a lot of discussion about all those smart projects. These were mostly as concepts, but to visualize what I believe can be done is I want to show you a little demo of the smart city project that we actually had with the city of San Francisco. Our CTO has a pleasure of being a part of the advisory board there, responsible for security. And that smart city project was about connecting things to the services in a secure way. before I tell you how it was done, I will show you what's behind it. I will show you how this works. So it's not just a concept that is written on this whiteboard. It actually is something that works. So for instance, what I'm doing right now, I'm signing into my web application that is my smart city portal. To do it, I need to authenticate myself. And in order to do it, I use a protocol that is becoming widely used in the federation world that is called OpenID Connect, that allows you not only to authorize, but also to authenticate. And once I do it, okay, that explains a lot. Okay. So once I do it, I'm actually allowing access to information about myself, to my profile, to the department I'm working for. Currently, I'm logged in as one of the technicians that is responsible for servicing different things. Like you can see here, I'm servicing some transformers, some flat sensors. So I can only see those because I'm authorized by means of the protocol that I just mentioned. I also can take a look at the map that shows all the devices that I can have access to. What I can also do is to check the status of each one of the device. This is important to understand. It looks simple, but what happens behind the scenes is me actually interacting with the device, and this interaction needs to be authorized. So I cannot do anything to the device. I shouldn't be able to just turn it off just because like that. I need to be authorized to do it. So if I log out and log in as somebody more authorized, let me check the view. It should be easier. I'll just stick with it. So when I log out as this unprivileged user or a regular user and log in as a user who's got more rights, then it gets more interesting. Better, thank you. So I have many more things that I can operate. So not only transformers, but also traffic lights and flood sensors and even cars. And this is also an important concept to understand. All of these might be provided by different IoT platforms. So the means of communication or the means of interacting with those devices might be different. And each one of the smart projects, like smart city projects, involves many different entities. So you're not getting all the devices from a single vendor. That's unlikely. You're getting devices from multiple vendors communicating with those devices using some specific protocols like MQTT or COPE, which are not meant to be used in the internet. But I'll explain it in a second. So I also see that I have some devices that are malfunctioning, and I can actually do something with it. so I can reboot the device. And again, what happens behind the scene, that command that I'm sending is checked whether I'm authorized to do it. I've got to accept it, so the device should be working fine. And I can see the map of the devices and see if it's really working fine. Yes, I see only one that is broken. Even more important thing from the utility perspective. So let's simulate breaking another traffic lights. So if I have malfunctioning devices and I'm the technician, I can look at the service route. And based on the several things, not only those sensors that I just showed, based on the GPS in my car, based on my cell phone, based on those smart devices, those traffic lights, I can be given the best route to fix the problem. So this is where I'm starting. This is my current location. I'm going to B, that's my first failing node. I'm going to C, that's my second failing node. And I'm then coming back home. So this was just to show that it's not a concept anymore, and it's actually happening in real-world scenarios. And it is important to notice that analysts see the importance of the identity in protecting IoT environments. So again, it's not only securing the device itself, it's also, maybe even more important, securing the way we interact with the device. And to do it, we need to introduce identity layer in each one of the services that we want to expose. So how? That smart city project that I was showing you, the Smart City of San Francisco project, this is what was used to simulate that. So we have an entity that is used to provision the device, which is one of the key steps in introducing identity to IoT security. So first, we need to introduce the device. The discovery process of the device is usually done by the by the IoT vendor himself. But now, all of those devices provided by that IoT vendor are only available in his own hub and connected via those protocols that I mentioned, like MQTT. Now, how do we expose those devices to the outside world? We usually do it by converting those protocols to something we know. And the perfect protocol for the internet is HTTP. So to do it, we use something called IoT Gateway that just does this translation. Then when any interaction with the device is happening after we provision the device, then it goes all through the identity gateway that introspects all those commands and what is coming back and makes the decision. Am I allowed to do it? Am I correctly authenticated? What's in that payload? Does it trigger any action? Should it trigger any action? And then, of course, we have that access layer, which is just a smart city app or mobile app, which is even more popular. And to add also to what Sandra said before, this is actually what she meant. So there is a growing number of not only identities, because that's trillions, or however we can imagine, the growing number of relationships between us, other people, devices, us and devices themselves, that's also growing. And this is the number that is quite scary. So it's expected to have billions of relationships in 2020 in regular size company program. So all those relationships is actually what matter most in the identity world. To add to that smart car example, one of the examples that we use is all that identity data is used for some purpose, and this is for actually driver's convenience. So when we log in to the car and to its system, then based on our profile, some certain attributes are being pulled. So we have our seat adjusted. We have the wheel position that is best for us. We have a map that is showing our favorite locations and stuff like that. Bluetooth pairing, everything. So it's based on those relationships that we have with things and that are coming from our profiles. So returning to the crucial security points, why we think identity is extremely important in IoT world. So if you think about a wearable or a IoT device, you have to think about its life cycle. So first, when we register or provision the device, we need to register its identity. And doing it safely, using trusted standards, protocols, is one element. Then we need to authenticate both the device and the user, not just the user, as we usually do. We log in with a username and password, and who cares what happens then. And then we need to establish a relationship between that device that was just registered, provisioned, with the user that authenticated correctly. Once this is done, the next thing happens, which is sharing data. So then we need to know which data is actually being shared. And if we want to share the data, we need to agree to that. That's one thing. And also, we want to agree with whom we want to share the data. This is also one of the problematic areas that I wanted to touch. We also need to have access control over the device and thing. We also want to make sure that when we lose the device, or if we sell the device, it's not going to the new owner with all the data that it contains. And of course, that's simply said, it has to all be done over a secure channel. So I mentioned standards. I don't know how many of you are familiar with federation standards using in identity and access management world. But there are quite a few, and I just picked some that represent those standards the best. And it is important to understand that not all of those standards are good for IoT scenarios. So out of all of those standards, there are actually 3 that are useful and that are being used widely. First, OAuth, which is meant for delegated authorization. And this is an important concept to understand as well. Delegated authorization, not authentication. We use services like Google, Facebook to authenticate as a social login thing. This is done usually by OAuth, which again doesn't care about how you authenticate. It only authorizes you. So whoever's got the token, and the token is something that is the key to the access, whoever's got a token has access. We just have information that the user was authenticated, but we don't know who was authenticated, how was authenticated, what's behind it. So it's like a key to the door. Whoever's got a key opens the door. Then there's OpenID Connect, which is becoming more and more popular, which adds an identity profile on top of OAuth 2. So now we know who the user is, and we know how it authenticated, because there is identity token associated also with that access. And there's also a new standard that is maturing. It's called UMA, User Managed Access. And the use case for that standard is having control of the data. So it's me responsible for my own data, and I know who I want to share the data with, and what data I want to share. So it's a good example of a family members. I have a pay TV subscription, and the subscription is shared with all my family. But I don't want my kids to access adult movies, for instance, or I don't want them to buy extra services. So I authorize them to watch only kids' movies, and I authorize them to buy only €5 worth subscriptions per month. And that's simply what Yuma is about. So the next things I wanted to show quickly is the whole process. So how do we do it? So we usually involve some sort of PKI to prove the device or the identity. Here, that's the regular use case when we register and authenticate that as a user. That's regular. That's something that we always do. Then we need to provision the device, and the device needs to be provisioned, needs to have some specific attributes, like it has to be an authentic device, it has to be a unique device, and if those are met, then we can have this device registered. For instance, if we are registering a device, and that device is holding a key, a certificate, actually, so we can pull information about that certificate, pull the serial number of the certificate, check it against the database, and see if it wasn't maybe blacklisted because somebody stole the device. One of the examples that I don't want to spend much time on, because we are actually running out of time. That's the example of device registration process and role of identity in it. So when we start the device, real quick, then we check if there's token, access token available on the device. We also generate a PIN. And that PIN is only valid for a short period of time. To register the device and associate it with us, we need to sign up to the web portal, register to the web portal, enter that PIN, and when the PIN is correct, then the device is registered and paired with us. And the other scenario for authorizing access is when we have the device already paired and registered. So we go to the user account, we log in, it's being checked if it is an existing account, if it's an existing relation. If it's not, then we can choose to wipe the device or re-register the device. If the token is right and still valid, then we can have access to the data in the scope that is defined. We also need to have a way of claiming the ownership of, or having a proof of possession of the device. So again, it's all about creating a relationship between us and the device in a unique way, so that nobody can forge that this device belongs to somebody, to claim that this device belongs to somebody else. We usually want to authorize that device to send some data outside. And we want to explicitly say that we are authorizing this device. It cannot be done just because we're connecting the device. It's already authorized to send any data and share the data. And again, we are using here the notion of tokens. In this example, auth2 tokens. We also want to know or make sure that once we authorize that device can send the data on our behalf. So it's delegating authorization to that device and still associate that data to us. And the last scenario that I mentioned, the final one, I lost my device, I sold my device, I don't want to use my device, so I revoke access tokens that makes basically the device inoperable in terms of accessing that. The new notion, as the absolutely last thing that I want to say, is the concept of sharing data, using the example that I gave about the family members and those subscriptions that those family members might want to have. So it's all about giving all about consent that we give to things to do things, or revoke that access. So we want to share just part of the information, like with wearable health device wearable. We want to share some data of it with the doctor for a period of time. And we want to know if the doctor shares that data with somebody else we didn't directly authorize. So I was talking about the IoT and smart cities and what was used, and this is actually what was used by product names as a final thing. So for connecting the device to the broker, we used ARM device server that was understanding that MQTT protocol. Then we passed it through the identity gateway that we call OpenID, that introspects the traffic. And then based on the results, the device is authorized to send the notifications to the system or receive the commands from authorized entities. And for pure security perspective, we can also get all the information from that environment and feed it into security monitoring solutions. A good example would be FireEye. We enable a FireEye platform to use some identity data to make their analysis more thorough, including that identity part that it's been missing. Thank you. It's pretty much all I wanted to share with you. And of course, I'm waiting for the questions. If not, we're in the booth on the -1 level. So please come by and we can discuss any topic you think might be worth discussing. Thank you.